Hi there guys, I'm Chris Bowden and you're not. Welcome to the Geek Group, where today we are playing with awesome chemistry and physics. Because I have something that I should probably never be allowed to own. That is a full liter of ferrofluid. Oh yes, I have a liter of ferrofluid, which is a fabulous way to spend a couple $100. Now, there's a million ferrofluid videos on the internet, and they're all the same video. Have you noticed that? They're all the exact same stuff. It's goop in a container, moving. Nobody ever talks about it. Nobody ever talks about what it is or how cool it is or how just, it's ferrofluid, man! This is neat stuff! Nobody talks about it. They're like, oh, it's art and it dances. Shut up! Let's see how it works. Play with it. All right, so this is ferrofluid. Now, this is what you need to know. First off, it stains everything it touches. Just accept this and move on. It will stain your skin so bad. Oh, wow. What gets it off? Because this is the second thing that you need to get. When you get ferrofluid, which is ungodly expensive, but when you get ferrofluid, you need to get something cheap to go with it. You need plain old lacquer thinner. That's the stuff you want. Lacquer thinner. Works great. I've spilled it on a table several times because I'm me. Takes it off all kinds of stuff. Lacquer thinner also takes other things off like paint, varnish, so be careful with it. Test it on a small, unobtuse area of the object before you, just don't sue me when you screw up your mom's $800 coffee table. So yeah, ferrofluid is very, very, very messy stuff. Be careful when you play with it. I got a whole stack of these. Got a whole stack of cheap, nasty, like dollar store plates with slightly raised edges. So what this will let me do is this. You can get these, by the way, at any pharmacy for like $1. They make great pipettes for playing with ooky goop like this. But watch, we'll put this right in the middle, and that's your ferrofluid right there. Okay, it's migrating for one. So we'll set that aside. Look, I've got another plate. Yay! So we'll set that out on there. Now it's oil. It's black goop on a plate. But the minute you grab, oh, that sounded really good. The minute you grab a good solid magnet, come here. Ah, okay. Now this is, if you just watched our hard drive equipment autopsy, this is a standard hard drive magnet. Now you want to be careful because that's going to want to attract to this. So you don't want to come in sideways. You want to lift it up and come in under it. Now watch the goop in the plate closely. As I bring the magnet up from below, see it swell up? Just like that. Now I'll do it again because I just popped some bubbles on the tray there. Watch, as I come up from below, it's totally liquid now. As I come up, see it start to bow? And then it starts getting little spikes. Those spikes are the lines in the magnetic field. Those are lines of flux. And as I move this around, I can clean up the extra ferrofluid on there. Now I'm going to set this down right here. I'm going to grab my little dropper and bring my things over so they overlap so I can't get any on the table. And we're going to pick up some more. Now watch this. It's sucking it right out of there. Can you see that? It goes into the thing.
I think you're going to want the adventure cam for this.
Yeah, the adventure cam's catching it, I think.
Okay.
But look, I can grow my blob.
I can tell you that I just get blackness in a bow line here.
Yeah, it's fine.
No detail.
Now I've got a pretty sizable blob of ferrofluid and some little drippings around. Let's try one more. This is so cool. Now ferrofluid is basically a carrier, like a buffer solution, which I'm guessing is some manner of oil or whatnot. I don't think it's water-based. And in it, it's a colloidal suspension of, I'm going to put the cap on that. because if I knock that over, oh my God, the mess. It's a suspension of little tiny nanomagnets, like super tiny little magnet particles. And when it's in a liquid state and there's no magnet near it, it isn't magnetic. Ferrofluid itself is not magnetic at rest because all the little magnets in there move around and they zero each other out, and it's a net zero, so it's not magnetic. But if you put it in the presence of a magnetic field, neat stuff happens because they all move and turn into alignment. And that's why you get these little flux pointies sticking up. Now I have to put, because I just realized I did something kind of dumb, I have to take some of that out of there and put it back in the bottle, because if I take the magnet away, I think I have too much there and it'll make a mess on the table. So I can go right into the pile here and suck some out and put it back in the bottle. It's so neat. Ferrofluid is one of those things that's just fun to play with. It's very messy, and it's not the good kind of messy. It's not messy like mud or messy like non-Newtonian fluid or cornstarch stuff. That stuff's incredibly messy, but it's easy to clean up. This stuff is a nightmare, and I've just been playing with it for 5 minutes and I already got all over the table and But just to show you, move that out of the way. Just grab a paper towel, grab some lacquer thinner, and it comes right off. See? Super easy. It's okay, that's the lacquer thinner cap. If that was the ferrofluid cap, I'd have a pretty healthy mess. But this takes it right up, and it'll take it off your fingers too. And for all the people who are about to complain because, oh my God, he just tossed a lacquer thinner soaked rag in the trash, and that's a fire hazard, and, oh, shut up. I got a burn barrel. Ha, there, see? That's my trash can. I come prepared. Back off, man, I'm a scientist. All right, now let's take a look at this. We'll take this off the bottom, and you'll see the magnet will stick there. Okay. Now here's the really cool thing. If I turn it, now I'm going to have faith in my science. You ready? 1, 2, 3. There's the ferrofluid right there. Sticks to the bottom. Zoom right in on that. See it? There it is. There's a big blob of ferrofluid. And it stays there, and I'm holding the magnet. The ferrofluid is holding the weight of the plate and the ferrofluid. So I can turn that right over, and there it is. It's really, it's neat, man. It's actually on there really well. All right, now I'm going to take the magnet off. You can see, as soon as the magnet goes away, now I've got a big puddle on the table. All right, so I'm going to set the magnet aside, way over there. Let's grab a different magnet, because I like magnets. I got a bunch of them. This, and this is really what they're called. For all the city people out there who don't believe me, you can check, find a farmer friend, or Google it or whatever. That is a cow magnet. And you actually do feed these to cows. You get it back at some point too, but I'll leave it to your own imagination as to how you get the magnet back. But yeah, this is a cow magnet, and they are awesome. And if I bring my cow magnet under it, there you go. See those spikes? Magnetic flux. And I can move it around. That is so cool. Can lay it down. See, you can see the flux on both ends. There's a little nub on the bottom of the tray from the injection process. Look at that. That's so cool. Now, I got this ferrofluid for a project, a geek group project we're working on. I've got some little tiny, I'm just gonna put that on there. I got this for a project we're doing where I'm going to be doing a science art sculpture demo thing. And, oh look, they sent me, when I ordered the ferrofluid, they sent me a little tubey thing of different magnets. Now this is neat because I've got a cube magnet. Here, I'll push that way out of the way. But look here, I've got a cube magnet, that one, which is about a 1/4 inch cube. Then I've got a ring magnet, which is about, I don't know, 3/8, maybe a 1/2 inch ring, if that. And then there's a disc. So I'm gonna do these one at a time. Let's take a look and see what different magnets do under the ferrofluid. So I've got a cube here. So I'll put the cube under it. Now the cube gives us a ball, which tells me that's not a pole, that's a side. Now if I turn it 90 degrees, that's one of the poles. Okay, so as I come up, that's a pole. If I turn it, I can't flip this over because I don't have enough, but can you see under there?
A little bit.
A little bit? Okay,
Here,
you
let me
can zoom in. You get the bottom when I hold it up there, and we'll work this out. All right, there's the cube. Okay, I'm going to bring it down here, and you can see some spikes. It's a really tiny magnet, so you don't get a lot of spikes. The spikes show the lines of flux. Now I've just got a ball there, because that's a side of the cube. We bring up another side, and there's a couple spikes. It's just a couple, because it's a tiny magnet. The smaller the magnet, the weaker the magnet, the less spike you get in the ferrofluid, because those are showing the lines of flux, which is why if I go and grab like the big cow magnet and show that on there, there's lots of spikes all of a sudden. Huge, because it's a cow magnet. Now the spikes are at the end. Okay, you can see them right there. You can see the magnet under it. And the spikes come off the top. If I put it flat, there's spikes at each end. See? So the spikes are right where the magnetic flux lines are. Now the spikes, this is hard to visualize if you don't understand how magnetic flux works, but let's see if I can draw it out for you. Can you follow me back to the whiteboard here? All right. Let's say we've got a cow magnet like this. Okay, that's our big cow magnet. In that magnet, the magnetic flux, the force, the magnetic field coming out of the magnet comes out in bands like that. And they connect. They actually go out one side and back in the other. Okay, so the little spikes you're seeing, if you cut this off, now if you imagine the fluids up here, what you see, when you get rid of all that, is little spikes, the points where the field comes out. So what you're getting, if you have the plate here, and you have a line of magnetic flux, put your magnet there, the magnetic flux comes out and then back down like that, you'll get a little bump in the fluid right there like that. And the more of these, the stronger the magnet, the more flux it has. So a weak magnet might have like just a few lines of flux like that, but strong magnets have more and more and more. So you can tell right away when dealing with the ferrofluid how strong the magnet is and how many lines of flux and all that jazz. It becomes apparent. The ferrofluid allows you to visualize something that is normally invisible. You can't see a magnetic field. It's just like magic. They just stick to each other, and that's cool. So we saw what a cube looks like. There's a screw under there. That's kind of cool. All right. So we saw that. Now let's see how the ring is magnetically polarized. Take a look. I'm going to bring the ring up. Lay it flat. Now look at, oh wow, look at that. Check that out. I don't know if it's showing up on this camera at all, but it's really cool. You can, when I did it at first, here I can't get it off the bottom. Give me that back. Ah! All right. Now I've got most of the fluid down in the corner so it doesn't flood. But if you watch this, if I put the ring magnet, now this magnet is a hollow ring. If I put the ring magnet under it, a hollow ring appears on the fluid on top. And now it's wicking up fluid from all around. There it is. Now you can see it. It's wicking up fluid around it, so it's hollow. Now as it picks up some more fluid, see the ring gets bigger? And you can see the flux lines form. and then it floods out. You just get a lump. That's really cool. I'm gonna try that again. I wanna make sure we get some good shots of that. All right, I move all the ferrofluid away. So I tilt the tray this way so all the ferrofluid's down here. I come up on this end where I've only got a little bit, and I take the ring, I put it right there. You can see right away where the ring is, and it sticks. Now you can see that in the center of the ring, zoom right in on it if you can see it. You can see in the center of the ring, it's hollow. And the ring is getting thicker and thicker as we go, because it's wicking up the ferrofluid around it. And if I move it around, it cleans the area. It's actually really good at that. All right. Now if I let the fluid come back, if I tilt the tray over, watch what happens to the ring. It'll get thicker and thicker really fast. And you can see the flux lines forming. That is so cool. And it just keeps building. And if I bring all the fluid back, I just get a big lump. I don't even have to bring fluid back. I can bring a magnet to it. I can bring the mountain to Mohammed. All right. So that was actually really unexpected. That's cool. All right. So let's try, we'll put that one over there. Let's try the disc magnet, which is on there pretty well. Here's our disc magnet. That's on edge, and I can roll it back and forth, which is kind of cool. Flip it flat, and the spikes come up. And there's our spikes. So that tells me that the poles on the disc, on this particular disc magnet, and is not always the case. Most of the time, the poles on a disc magnet are the two flat sides, like this is north and that's south or something like that. But you can get disc magnets that are polarized by halves and stuff like that. So yeah, there's your magnet mojo for the day. And a quick look at ferrofluid. Now you have ferrofluid in your home. You can find it, but when you find it, it'll typically be in really tiny amounts. You'll only find a few drops. Ferrofluid is used in hard drives for bearings and cooling. It's used in speakers for cooling. It's used in electric motors for seals and stuff like that, because it's a fluid that you can control very easily with a magnetic field. So there are a lot of uses in industry for it. It's been out for quite a while. It's just the kind of thing that most people don't get to see and play with. And you should, because it's quite nifty. I'm going to grab our big cow magnet. No, I'm not. I'm going to use that one, that hard drive magnet, because that cleans it up well. I'll put that right under there. I can just mop this around, and it'll suck up most of it. And take this, because man, when you play with stuff this expensive, you don't want to waste any more than you have to. So that's ferrofluid. We're going to be doing a lot more with this. This was just a basic introductory video because I got a neat new toy and I had to share it with the guys because, you know, it's cool. I can't have something this neat just sitting on a shelf for months on end and not share it with you guys. And that's how you clean it up. You put a magnet in the middle of the tray and suck up as much as you can. Set that aside. This is why you want to use square trays and not circular ones, so that you can pour it back in the thing and get a lot in there. And you can use this magnet. Now look, that just, it's all poured off, right? There's only a few drops left. Okay, we're done there. Now I take this and put on there. I can get a whole bunch more. This'll super clean it. And you can actually see it getting sucked in there. I don't know if you can catch that on camera. Try zooming in. But you can see it sucking up to the magnet. So ferrofluid, you'll never get it all off, but you can get a lot of it. And the stronger the magnet you use, the better this will work. For those of you wondering why I made the weird pattern on the bottom doing that, it's because there's the nub right there. I do work around the nub. So I take that back to a corner. I get this corner as good as I can. Hold it over the thing, pull the magnet away, and the fluid will fall. Right there, you want to catch that? Now watch, I pull the magnet away. and the fluid falls down into the bottom. This is so neat. I'm just mopping it up as I go around. If you zoom in really, really tight, you might be able to see the cool stuff that's doing. I'll go down here and see what I can get on that camera too. It's just eerie how effective that is at cleaning it up. See, if we could clean up real oil spills this effectively, we'd be set. That's so cool. All right, so that's a quick look at just Ferrofluid 101. We're going to get a lot more into it. We're going to go into detail of how you can make it. We're going to go into detail of how it works and why it does the things it does and what you can do with it and all that jazz. And we're going to make some really, really awesome projects with it. Because this is one of those things where the geek group can spend a pile of money to buy a very expensive thing that normal people don't really get to play with and experience, so that we can make videos and share this with you guys. That's what we're here for, is sharing this stuff with the world. Now I want to see just how effectively I can clean that off of there. I'm going to put my magnets well away. When you guys donate, when you send in, you know, those $10 donations, it's to buy stuff like this. It's to let us make these videos. That's what it's about. Now this one's dry. I don't have anything on it yet. I'm just going to fold it up and just see how much of that I can clean up. Now remember, this is an oil, so that's about as good as that's going to get. Now I got a fair bit on there. It's pretty black. Now let's try level 2. Da, 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 da. I'm going to take ta-da! Look at that. See? I made a serious improvement. We're actually getting some white. It's like it's scratched. Oh, I'm crazing it because this is just polystyrene. See, this is why you gotta be careful with lacquer thinner. This is actually melting the plastic a little bit. Yes, I have now etched this plate. It is permanently destroyed. This would have been fine with glass, very bad with plastic. It is forever hosed. Cool. Sorry, Mom! You know what's going to happen now? My mom's going to message me on Facebook going, why are you saying that? Why you got to make fun of me? Why you got to pick on me like that? I love you, Mom. It's not your plate. It's the ones Grandma sent me for Christmas. No. But yeah, there. Now you've. We ought to do a video on the cool properties of chemically melting plastic. Any of you guys who have ever used model glue, when you use model glue, just the regular tester's model glue, it's actually melting the plastic. Let's try this. Watch this. I'm going to take a plate, white plate, brown plate, okay? I'm not going to screw up my good little plastic thing. I'm going to set that aside. But I'm going to grab... I actually need a glass pipette to do this right. All right, I'm going to try and fake it. It's a totally different thing. This is just... I'm just screwing around. I don't know if this will work. I have no idea. But I'm going to try for science. It's an experiment. I should probably be wearing eye protection, but I'm not. So OSHA can bite me. All right, I'm going to put a lot of lacquer fluid, or lacquer thinner, on there. I'm going to wipe this really thoroughly, all around the top. Get it really, really wet, as wet as I can. The problem is I don't think I can keep it that wet for that long. But when you use model glue, it actually does what's called chemical welding, which is where the glue doesn't actually adhere the two pieces of plastic together. What it does is it melts the two pieces of plastic, and when you push them together, well, the glue evaporates, basically. The lacquer thinner, in this case, is melting the two pieces of plastic here, and it evaporates quickly. And when it evaporates, the two pieces of metal fuse together and they're welded. It's the same as a heat weld. And that's how model glue works. Yeah, I think it worked. All right, here, we'll throw that away. Give that a second to dry. Now watch this. This is cool. See the plate? I'll grab the top plate. The bottom one sticks to it. They're welded together. Not very well. I wouldn't, trust it very hard. They'll very nearly fall apart. But if I hold just the back plate, they stick together. I'll grab my Gerber so that I can hold just one of them and show you that. Here. There. Ta-da! And that's how chemical welding works. So we started playing with ferrofluid and ended with chemical welding, which is not at all where I expected to be, but hey, that's cool. There's your science for the day. I'm Chris Bowden with the Geek Group. You guys have fun. If you have ideas for ferrofluid stuff, send them in. Please remember to rate, comment, and subscribe. But really, the one that I care about the most is that you comment and subscribe. You can email us at info@thegeekgroup.org. You can find more information about the cool stuff that we do, like the actual projects that we're going to use the ferrofluid for, at thegeekgroup.org. And if you're watching this video this long, you should be a member because you're weird, you're one of us, you're a geek. It's a badge of honor. Be proud. See you guys later. Have fun.
This video was made possible by a grant from the Future Girl Foundation.
This video was made possible by thousands of private donations from members and viewers like you. Please visit thegeekgroup.org for more information on how you can donate and become a part of our dreams of Avalon.